Why does an apple fall to the ground? Why do planets orbit the sun in a predictable way? And why does light bend as it passes near a star or massive object? In classical physics, these phenomena are usually explained in one of two ways. In classical mechanics, gravity is viewed as a force of attraction, while in Einstein's theory of general relativity, gravity is explained as a warping of space-time, where massive objects curve the fabric of space, and everything follows the straightest path along this curvature. However, in energy filament theory, we look at gravity from a different perspective, one that is grounded in a more intuitive underlying image. Gravity, in this theory, isn't an invisible hand pulling objects towards each other, nor is it simply an abstract idea of space-time being curved. Instead, gravity is best understood as a tension slope in the energy sea that permeates the universe. Let's use an analogy to explain this. Imagine the entire universe as a giant elastic mattress. In some areas, massive celestial bodies like stars, planets, and black holes create deep, tight depressions in this mattress, while other regions experience only slight, shallow indentations. Now, if you place a small ball on this mattress, it doesn't need to be pulled by an external force. If you simply let go, the ball will roll down the steepest path, naturally following the direction of least resistance. The pattern of how the mattress is shaped, where it's tighter and where it's looser, forms what we can think of as the gravitational field. And this is the tension slope that gravity creates. The apple falling to the ground is not simply being pulled by gravity. Instead, it is following the tension slope created by Earth's mass pressing into the fabric of space, much like the ball rolling down a mattress. Similarly, the planets that appear to orbit the sun in neat elliptical paths are actually moving along the contours of a three-dimensional tension terrain. The path they take is the one that avoids falling into a pit while also staying within the valley formed by the tension landscape. The planets find a path that is in perfect harmony with the shape of the energy sea, staying in orbit due to the structure of this tension field. Even light, which seems to bend as it passes near massive objects like stars, is following the same principle. It may appear as though the light is being pulled, but in reality, it's simply following the most natural path along the tension slope created by the massive object. This bending effect, often seen as a curvature of light, is just the light's natural response to the changes in tension in the energy sea. This view of gravity shifts the way we think about gravitational fields. They are no longer seen as external forces acting upon objects, but as part of the fundamental structure of the energy sea itself. The gravitational field is essentially a map of where the energy sea has been compressed or stretched, creating slopes of varying steepness and tension. Objects, light, and even the passage of time itself are simply reading this map of tension and following the path of least resistance along it. When we talk about gravitational potential or gravitational acceleration in this framework, we're really talking about changes in the height or slope of this tension map. When you move through different areas of the energy sea, you're either moving higher or lower on the tension map, or you're encountering a change in the steepness of the slope beneath you. The feeling of gravity, then, is simply the experience of moving along this tension slope. Once you begin to think of gravity in terms of a tension slope, it becomes much clearer that what we traditionally think of as gravity is just the manifestation of these tension changes. Whether we're discussing Newton's law of universal gravitation or Einstein's curved spacetime, both ideas are essentially different ways of describing the same underlying concept, the changes in tension in the energy sea. In energy filament theory, gravity is not a mysterious force or an abstract concept. It is a physical, measurable properties of the energy sea that affects the way objects and light move through space. So, when you look at concepts like gravitational force or spacetime curvature, try to imagine them as different views of the same tension slope. One perspective describes it as a force, while the other describes it as the bending of spacetime. In energy filament theory, gravity is simply the shape and structure of the energy sea, and objects, light, and even time follow the natural paths laid out by this tension terrain. Tap follow, share it on New Physics, Clear Universe.